Hello class, in today's calc lesson we're going to work on finding limits using substitution. So let's do this quick warm-up just to get us started and kind of review what we did yesterday. So in this warm-up you're going to use a table to evaluate the limit as x approaches 3 for the following functions. Now again, when we're using the table we want to look at what that limit is and look for values just above and just below it. So what I've gone and done is I have used Desmos again to graph the function, and I started to substitute values in for x as you can see here. Now we did 3 just to make a point. At 3 the value is undefined, which makes sense because if we had factored the entire function we would find that we were able to cancel out the value x minus 3. And because we're able to cancel out x minus 3 it means there's a hole in our graph. But when we look at the values just above and just below 3 it looks like it is converging towards 4.5. So for this particular function, you're going to find out that the limit as x approaches 3 is 4.5. And again, on your calculators, you're just going to want to substitute this value in and find out what x is equal to. We can also, if you remind me, we can show you how to add this into your calculator and create a table where you can ask these values so you're not having to do so much of the grunt work. But let's go ahead and get started. At the end of this lesson, you should be able to determine the limits of continuous functions. Now, when finding the limits of continuous function, we need to define that. So a continuous function is one with no breaks, vertical asymptotes, or holes. These are typically polynomials or sine and cosine values, or sine and cosine functions, but not the other trig ones. So in order for a function to be continuous, the limit as x approaches a for f of x should be equal to f of a. What this is saying is that if I were to substitute in this value for a into this function, we would have a function that worked nicely. So let's do a couple example problems. As we take a look at example A, it said what is the limit as x approaches 4 for 7? Now keep in mind that our function here is 7. So because there's no variable, that value is going to remain a constant. That's why it's called a constant. So the limit as x approaches 4 for the function 7, that's equal to 7. If we do the same thing for part B, what we're saying here is that 3 times 2, because the limit as x approaches 2 is what we're looking for, minus 5. So 3 times 2 is 6, 6 minus 5 is 1. So the limit as x approaches 2 for 3x minus 5 is equal to 1. Part C, same idea. We're just substituting the value in. So 2 times 1 plus 1 and 1 minus 3. What this does is this gives us a fraction that is 3 divided by negative 2. So the limit as x approaches 1 for the function 2x plus 1 all divided by x minus 3 is negative 3 halves, or 3 divided by negative 2. Moving on, let's look at part D. It says the limit as x approaches pi for sine of 2x. So again, we're just substituting these values in. Sine of 2 times pi is equal to sine of 2 pi. And sine of 2 pi is equal to 0. So the limit as x approaches pi for sine of 2 of x is equal to 0. Pretty simple stuff, I hope. Now these are a couple of problems that I'd like for you to try. So this would be a great time for you to pause your screen and try solving these on your own. When you're ready, go ahead and press play and I will go over their answers with you. So hopefully you've paused your screen and we're just doing A through D. Now again, in part A, you'll notice that the limit as x approaches negative 3 is for a constant function. Therefore, the limit shouldn't change. The answer should still be 4/3. For part B, the limit as x approaches 2 for the function. We're just, again, substituting these values in. So we're going to go ahead and get 2 quantity squared plus 4 times 2 minus 5. So 2 squared is 4, plus 8 minus 5 is what we're looking at. Your final answer is 7. So the limit as x approaches 2 for the function is equal to 7. Same thing for part C. We have 1 plus 2 times 1 minus 1. Well, you'll notice here that this is equal to 3 times 0, which is just 0. So the limit is 0. Last but not least, cosine of pi. And cosine of pi turns out to be negative 1. So the limit as x approaches pi for cosine of x is equal to negative 1. So I hope this has all helped. We'll have more time in class to practice today, but that's all for now. I'll see you guys next time.